This video is going to be all about LOD, or level of development, in BIM. We're going to establish what it is, we're going to define why is it important, and then I'm going to give you a very detailed explanation of each of the LOD levels, so you can use this as a quick manual. If you don't like reading, you can view it in a video format. Let's go. Now quickly, before we jump into the actual video, I would like to take a moment to tell you about today's video sponsor, Cogram. This is an AI project admin specifically designed for architecture and construction domains that allows you to accurately create meeting minutes, project reports, or briefs. Let's see how Cogram actually works. On a simple meeting, this can be a virtual meeting such as one on Zoom or Microsoft Teams, a hybrid meeting, or an in-person meeting such as on-site visit. So if I click on the meeting, you can see that it has produced a transcript on the left-hand side, and on the right-hand side we have a high-quality summary, bullet point notes, and action items along with their assignees. Two things are unique about Cogram. It is able to summarize conversations on an in-person meeting such as on-site visit or in a conference room, and the second thing is it's able to export minutes directly into your project minutes document, such as if I go here and click on download, you can see that it has exported meeting minutes directly into our template, including our formatting, heading, and our content requirements. So this mobile app can transcribe the conversation as you're having your on-site visit and document every single conversation that you have to create your meeting minutes. However, the mobile app also has photo taking capabilities, so you can use it to take photos as you complete your site walkthrough and annotate those photos. Cogram will then add your annotated photos to your meeting minutes to create a complete visual report that you can share with other stakeholders. If you would like to check it out, I'm going to be including a link up in the cards above and then also down in the description of this video. And now let's get started by asking the question of what even is LOD in BIM. We have to be careful here because the acronym LOD can be used both for level of detail and level of development. The BIM level of development measures the amount of information represented by a BIM element. It defines the detail and accuracy that should be included in a BIM project at different stages. This has been developed by the American Institute for Architects, or AIA for short. This is not the same as level of detail that concerns the graphical details added to a model. Now let's discuss why is LOD in BIM even important. Well, for that we have several reasons. The first one is clarity and communication. LOD provides a common language for all stakeholders, which would be architects, engineers, contractors, and owners, ensuring that everybody understands the model's detail level. For instance, during a project meeting, referring to LOD 300 clarifies that the design is ready for construction documentation. Next thing is risk management. Different LODs help identify potential risks at various stages. For example, in LOD 200, you might spot a design conflict between a structural element and an MEP system early, allowing for adjustment before the construction begins. Then we have cost estimation. With accurate LOD supports better cost estimation. At LOD 300, for example, detailed elements allow estimators to provide precise material quantities and labor costs, reducing the budget overruns later on. LOD in BIM is also important for scheduling and planning because higher LODs facilitate better scheduling. When using LOD 400, contractors can plan specific fabrication processes and timelines since the model includes detailed connections and materials. Then we have facility management. LOD 500 provides a comprehensive as-built model that aids in facility management. For example, maintenance teams can use the model to locate and service the HVAC systems, accurately improving efficiency. Finally, we have collaboration. LOD enhances collaboration among disciplines in a multidisciplinary project. A clearly defined LOD helps ensure that everyone's contributions align with project's goals and timelines, minimizing rework. In summary, LOD is vital for clear communication, effective risk management, accurate cost estimation, better planning, efficient facility management, and enhanced collaboration through the project lifecycle. LOD in BIM streamlines communication, enhances efficiency, ensures consistency, and controls cost throughout the construction of the project. By adhering to LOD standards, stakeholders can navigate complexities with confidence, ultimately revolutionizing how engineers conceive, build, and maintain structures. So now that we have established what LOD is and why it is so important, let's now accurately define each level individually. There are 6 levels. The American Institute of Architects, or AIA, and the Associated General Contractors of America, AGC, have established a commonly used LOD framework, and it starts with the first level, LOD 100, also known as Conceptual Design. So LOD 100, or Conceptual Design, represents elements' basic shape and size without detailed information. It conveys the overall design intent. Design intent outlines purpose, goals, and aspirations behind the building or space. By defining an intent early on, architects and designers ensure that the subsequent decisions align with project's overreaching goals. Then we have conceptual sketching and diagrams. Sketches and diagrams capture initial ideas and concepts. They're a visual representation of design intent. Sketching allows designers to explore multiple options rapidly. Diagrams clarify spatial relationships, circulation patterns, and key design elements. Then we have spatial organization, which defines how different areas within the building relate to each other. It includes room layouts, adjacencies, and flows. Well-organized spaces enhance the functionality, user experience, and efficiency. Proper circulation paths ensure smooth movement. Then we have the massing studies. Massing studies explore the overall volume and shape of the building. They consider factors like site context, views, and daylight. Massing studies help architects understand how the building fits into its surroundings. They inform decisions about orientation, setbacks, and visual impact. Next, we have site context and integration. So site context includes neighboring buildings, landscape, topography, and climate. Integrating building harmoniously with its context ensures contextual relevance, minimizes environmental impact, and maximizes views and natural resources. And we have sustainability concepts, which obviously, sustainable design principles address energy efficiency, resource conservation, and occupant well-being. Early consideration of sustainability leads to a better long-term outcome. This reduces energy consumption, lowers operating costs, and supports a healthier environment. Now let's move to the second level, which is LOD 200, or Schematic Design. The model becomes more refined, incorporating approximate quantities, sizes, shapes, and locations of elements. It helps analyze spatial relationships and early design concepts. So here we are first refining shapes and quantities. So at LOD 200, the BIM model evolves from a basic geometric representation of LOD 100. It includes more detailed shapes, approximate quantities, and sizes of building elements. Architects and designers use this level to enhance spatial representation and refine the project's layout. Next, we have approximate locations. So for LOD 200, we introduce information about the location of elements within the design. While not precise, it does provide a better understanding of where components will be placed in the building. We have basic material types and properties. So the model at LOD 200 includes basic material information. This helps stakeholders visualize the project with a more realistic representation of materials, even though specific details are still lacking. No detailed connections or assemblies. So unlike LOD 300, which we'll talk about in a moment here, LOD 200 does not delve into intricate connections between elements. It focuses on individual components rather than their interrelationships. This level of development is used in scheme development, so architects and engineers rely on LOD 200 during the schematic design phase. It aids in refining the initial concept, exploring design alternatives, and evaluating spatial arrangements. Cost estimation and building visualization is important within LOD 200s. The models assist in estimating project cost and providing more accurate quantities. Additionally, they enhance visualization, allowing stakeholders to better understand the project overall form and layout. Now, let's move over to LOD 300, which is detailed design. This includes geometric information, specific sizes, shapes, and detailed object components, used for producing construction documentation and coordinating different disciplines. LOD 300 represents a pivotal stage in building information modeling, or BIM, where the model attains a higher level of detail. Here are the key points about LOD 300. Precise element geometry. At LOD 300, the BIM model includes accurate measurements and relationships between components. This level ensures that the geometric representation is highly detailed. Specific material types and key performance data. So the model provides information about material types, their performance characteristics. This helps stakeholders make informed decisions during the construction process. Then we have the simple connections and assemblies. So LOD 300 introduces basic connections and assemblies between elements. It aids in understanding how different components fit together. Use in construction documentation. So of course, architects, engineers, and contractors rely on LOD 300 for producing detailed construction documents. These documents guide the actual construction work on site. Coordination across disciplines. So LOD 300 facilitates coordinating among various disciplines such as architecture, structural engineering, and MEP systems by providing a comprehensive and accurate representation of the building design. Now, let's move over to LOD 350. So the fourth level is not LOD 400, it's LOD 350. This is construction documentation. It includes detailed assemblies and fabrication of construction level information used for generating construction documents and shop drawings. So here is a concise exploration of LOD 350 or construction documentation in the context of building information modeling or BIM. So first we have detailed assemblies. So at LOD 350, the BIM model provides a highly detailed information how different building elements and components fit together. This includes precise assembly details, connections, and joint configurations. Fabrication level data. So LOD 350 includes data necessary for fabrication or construction. It goes beyond design intent and focuses on practical implementation. For example, it specifies materials, dimensions, tolerances, and other specific needs for actual construction. Then we have shop drawings. So LOD 350 models are used as the foundation for creating shop drawings. These drawings are crucial for contractors, fabricators, and subcontractors. They provide detailed instructions for constructing various elements within the building. Then we have coordination and clash detection. So LOD 350 helps identify clashes and conflicts between different systems, such as structural, mechanical, and electrical. It ensures that all components align correctly during the construction process. Next, we have use during construction. So contractors rely on LOD 350 to execute a project on site. It serves as a guide for construction process, ensuring that the building is constructed according to the design intent. And finally, we have bridging the gap. So LOD 350 bridges the gap between design and construction by providing the necessary detailed information for building realization. Moving on, yes, there is more. Next, we have LOD 400, which is Fabrication and Assembly. So this includes detailed models with specific assemblies and connections suitable for fabrication and assembly processes. LOD 400 represents an advanced stage in building information modeling, or BIM, where the model is specifically tailored for fabrication and assembly purposes. Precise geometry for manufacturing is really important, so at LOD 400, the BIM model provides exact geometric information required for the manufacturing processes. This includes detailed measurements, specific connections, and assembly details. Then we have fabrication level data. So LOD 400 goes beyond the design intent and focuses on practical implementation. So it includes information necessary for fabricators and contractors during the production and assembly phases. Then we have shop drawings and instructions. So LOD 400 model helps keep detailed instructions for the people who will build the different parts of the building. These instructions, called shop drawings, show exactly how to put things together. It's like having a step-by-step guide for construction. Efficient on-site production control is really important, so the LOD 400 model ensures that all measurements and details are super precise. This precision helps the builders work faster and more accurately on the actual construction site. And finally, we have LOD 500, as-built or facility management model. So this includes information about the installed and operational elements of the building, reflecting real-world conditions for maintenance and facility management. LOD 500 represents the final stage in the building information modeling process, capturing as-built conditions with precise accuracy. So this includes field verified model. So at LOD 500, the BIM model mirrors the constructed reality. It provides a comprehensive representation of all of the elements within the building, reflecting real-world conditions after construction. Facility management is also really important, FM for short. So LOD 500 models serve as invaluable guides for facility managers. They offer a dependable reference for operations, maintenance, and facility management. The data within these models helps ensure efficient building operations and upkeep. And that pretty much concludes all 6 levels of development in BIM. So you can always refer to this video, so when you hear LOD 200, you can come here and just rewatch and see what exactly LOD 200 is. Now, I would also like to warn you a little bit, because something that I've learned just from talking to different people in the industry, yes, it's nice we have all of these detailed levels of development. However, in real life, it's very hard to actually get people on the same page. So even though something has been defined as LOD 300, then you have some people thinking that that should include more detail and less detail. So always make sure that when you're talking to somebody, make sure that you're actually on the same page on what the level of development that you're discussing actually is. I mean, actually kind of in points. So try to kind of whip out the definitions and just make sure that you're both on the same page, because I've seen in real life that models that get either over modeled or under modeled just because people are simply not on the same page of what LOD 350 means. So it's silly, but it does happen a lot, so be careful. I hope you have enjoyed this video, and I'll be back next week with another Balkan Architect Revit tutorial.